In this video, we'll be covering Chapter 11, Section 5. It's going to be the probability with the fundamental counting principle, the permutations, and combination. So this video is going to be covering the different techniques and how to combine them in individual problems that require it. So let's look at an example. Number 1. 6 people have jokes, and then here are listed the 6 people. If the order of the jokes is randomly selected, what is the probability that the joke by the comedian whose first name begins with G is told first, and then the man's joke is delivered last? So although I have the answer here, I've always found it a little bit easier if we go ahead and list the possible solutions. What I went ahead and did is list the positions that the jokes can be told. It says here that a person with the name who begins with G's joke is told first. Well, we want to go over here and look for how many people who has a first name that starts with a G. Well, there's only one, so I'm going to go ahead and put that person's name here. He's the only person available, which is why I only have one here. There's only one person whose name begins with G. Okay. The last criteria is it has to be a man's joke last. So we're going to go to that last position and we're going to say, okay, Bob is going to be last. I'm going to use initials from now on. So Bob is going to be last. Stephen can be last. Henry, Jerry, Phyllis is a female. So here we have 1, 2, 3, 4 possible people who can be in the 6th position. That's where I get my 4. It's the number of men minus 1 whose name begins with the G. Alright, so then let's go to the 2nd position. Well, if one person has to be used here and one person has to be used here, then anybody else left, including the woman, can be in the 2nd position. Since we're talking about 6 jokes and 2 of them are designated to be in 1st and 6th, that means we have 4 possible comedians for position 2. We have 3 for position 3. We have 2 people for position 4, and then there's only going to be 1 person left for position 5. So this one has to go first. Any one of these can go second. Let's just say we use Bob. Then there's 4 people left. These 3 plus the female. So here could be S, H, J, or Phyllis, P, D. Okay? So once one of these people is used, let's say Jerry is selected to be in the 4th position, you can see that we only have 3 positions left, and those are these people's jokes. Okay, let's say in this position, let's say Phyllis is used, so we have 2 people left. Well, let's say that we end up using Stephen. That means Henry has to be designated for the 5th position. And this works for any of them, so it didn't have to be Bob. I could have said Jerry was used here, and that would have been replaced with Bob, and then so forth. So once you get all your specific numbers, all you're going to do is use your counting principles and multiply them together. So once I did that, I found out there's a total of 96 possible ways that a person whose name begins with the G goes first, and a man's joke goes last. Then we need to do is determine the total number of ways jokes can be delivered without any restrictions. So again, we have 1st, 2nd, 3rd, 4th, 5th, and 6th. Well, how many options do we have in the 1st position? Well, if there's no restrictions, we have 6 possible jokes. 2nd position, if 1 is used, we're going to have 5 possible jokes. 3rd, if 2 are used, we're going to have 4 left. The 4th position, well, if 3 are used, we have 3 left. 5th position, if 4 are used, we have 2. And then, of course, the 6th position, if 5 of them are used, there's only 1 left. So this is the same thing as 6 factorial. So the number of ways that jokes can be told altogether is going to be 720 different ways. So when we're talking about probability, it's a fraction, it's a proportion. There's 96 ways out of 720 ways where the first joke told begins with a person whose name starts with the G, and the last person who tells a joke ends up being a man. Once you put this ratio into the calculator, simplify it, and you'll get 2/15. Number 2. Number 2 says a minimum award of $50,000 is given to a player who correctly matches 4 out of the 5 numbers drawn from 69 white balls and 1 number drawn from 26 red balls. Find the probability of winning this prize and express as a fraction. And I'm going to find out how many different kinds of combinations we can get. The order actually doesn't matter because remember, when you're doing the lottery, as long as you have the numbers that are picked, it doesn't matter the order you pick them in. So we use combination. So I put the combination here. Well, how many balls do we have to choose from? That's going to be our n. And here our n, the larger number, is 69. So there are 69 numbers that can be chosen. And we're choosing 5 of them. So when we're doing this calculation, you plug it into the calculator, you get this gigantic number here. Well, the red ball options, if we only have 1 ball that is drawn out of 26, all we have to do is multiply it by 26 because we have 26 options. If you want to put this part in the calculator, you can. But if I put 26 and then I choose 1, you have 26. So I just simply put a 26 there. When we multiply these two numbers, this is how many different combinations that are possible when you're choosing 5 white balls out of 69 and 1 red ball out of 26. Okay, this is why playing the lottery, your odds are so small. Okay, there's a lot of choices and combinations that can be used. Now, in order to win, you need to match 4 out of the 5 white balls. So out of the winning balls, now I only have 5 balls that are winning, and you need 4 of them. So we're going to say 5 choose 4, because you only need 4 balls out of 5 to win, and that'll give you 5 options. So again, using your calculator, we're going to put 5 choose 4. There's 5 options. So that goes there. And you need the red ball to be correct. So there's only 1 ball that is correct on the red option, and you need to pick that number 2. So that is going to be times 1. So 5 times 1 is going to be this part here. Now, remember, it says here 4 out of 5, but we have to pick 5 white balls. So if there are 5 balls that are winning number balls, how many are not winning numbers? Well, if 5 are winning, that means 64 balls have not been chosen. So there's 64 balls here that do not win. And if we only pick 4 that are winning, that means we still have 1 that is not a winning number. So here we're going to have 64 choose 1, because you can choose 1 that's not winning, and then you need 4 out of the 5 balls that would cause you to win. So if you put this in the calculator, you get 64. Using the fundamental counting principles, multiply everything together, you get 320. That means if you're going to win the lottery, you have 320 ways of choosing a winning combination out of this many here. So that's what I have here. You only have 320 ways you can possibly win, and this is the total number of combinations. Your calculator probably will not do this. I'm going to go ahead and try it here because some of these numbers are really big. So what I did here was go ahead and do second PRB to try and change it into a fraction. As you see, it cannot go into a fraction. So what I would suggest here is if you look at these two numbers here, the 0 and the 8, those are both divisible by 2. So what I ended up doing was 320 divided by 2, you get 160. And then this number here divided by 2, and you'll get this number here. So this would be your reduced fraction, which is extremely small. The percentage here, remember when you have a decimal, you times it by 100, and here you would have like 0.0001%. So there's virtually no way that you're going to be able to pick a winning combination. Number 3, a club consists of 6 men and 4 women. 3 members are selected at random to attend a conference. Find the probability that selecting a group consists of, part A, 3 men. We need to determine if we are going to be using a permutation or a combination first. Because it says 3 members are selected at random to attend a conference, we can see that this is going to be a combination because these members are not being selected for specific roles where the order is going to matter. So we have 6 men and 4 women. That means we have a total of 10 people to choose from. So what's the probability that 3 men will be chosen? Well, we need to break this up. So I'm going to do 10, choose 3. That will be 120 ways. This is the total number of ways that 3 people can be chosen out of 10. Notice on this one, it doesn't matter if they are a man or a woman. We're combining both of those together when we think about the total. For the probability of 3 men, we do need to separate that into the men's group and the women's group. So here it says 3 out of 6 men and 0 out of 4 women. So when I do this part here, I'm going to say, well, the number of men, there's 6, and I'm going to choose 3 of them. So there's my 3. Times, remember that's the counting principle, 4 women, but we're choosing 0. So 4 choose 0. This comes out to 20, this comes out to 1, and then we use the fundamental counting principle where we multiply those options together. We're only going to get 20. But remember, a probability is a fraction, so we have 20 ways for 3 men to be chosen, and the total number of ways that 3 people can be chosen out of 10 is 120. The probability of choosing 3 men out of 10 people is going to be 1 out of 6. Part B says the probability that the selected group consists, now we're saying 2 men and 1 woman. So we're going to find out what's the probability of getting 2 out of 6 men, this is for men, and then 1 out of 4 of the women. Again, we're using combination because it's a group, it doesn't have specific positions, and then use the number n as your larger number. So 6 choose 2, there's 15 ways that that can happen, and then out of 4 women and we only want 1, well, there's 4 ways that that can happen. So if we multiply these two together, it's going to be 60. The total number of ways to choose 3 people out of 10 is still going to remain 120. There's a 1/2 probability that 2 men and 1 woman would be selected. So in this particular case, there's a better chance that 2 men and 1 woman would be selected than it would be of 3 men and no women to be selected for this conference. All right, that concludes 11.5. Let me know if you have any questions.